As hydrological model, we selected HYPE. HYPE is a semi-distributed catchment model which simulates water and other substances flowing from precipitation through different storage compartments like reservoirs, lakes, rivers, and fluxes to the sea. It has been developed by the SMHI, the Swedish Meteorological and Hydrological Institute. It is fully open source, so we can work on the code if you want to modify. It does not have a graphic user interface, so it works through TXT files. Everything is working through text files. Now I'll give you an example of how we work with HYPE into TwinLab. So first of all, we need to load the packages that are needed for run HYPE and visualize the data. Then we prepare two functions that we will use later. This is a typical Python structure, so we prepare the function at the beginning. Then we can run HYPE. HYPE is not written in Python, is an executable, so through this command line we can run the executable inside this notebook. Then it's asking me if I want to run it. Yes. And we can now HYPE is running. I already did dispatcher because it takes some minutes to run. It depends on the size of the catchment. Now I'm loading the matrix to check the accuracy of the model. These are the result of the accuracy. The model is not extremely accurate. It can be improved, but we knew this because for validating this model, we don't have many validation stations available, validation data. Then we can load the results for one of the catchments, the sub-catchments that I showed you in the previous videos. As you can see, the HYPE gives you a series of different data, evapotranspiration. This is the discharge, which is what we are interested in. This is only for one catchment, but then we can load it for all the sub-catchments, and we can do some analysis, like for example, here I'm extracting the average per hour, the maximum, the minimum, the standard deviation, etc. Then we can display it, and these are all the flows for all the simulated years. It's almost 5 years for all the catchments. These graphs have a light interactive capability, so we can zoom in, we can zoom out again, etc. We can move along the graph. Obviously, this graph is particularly difficult to read. We can also load only one series for one of the sub-catchment, but also we can run the average. This is the hourly average around the whole data series. So the first point is the hour between midnight and 1 in New Year's Eve. Here, the 0. Even this graph shows all the sub-catchments, so it's a bit difficult to read. These are how the data are. This is the average. But if we load and show only one catchment, it's a bit easier to see. This is a graph showing the average for each hour, but even the minimum and the maximum value for that data in our data series. So the flow data that we calculated with the hydrological model are an input data for TELEMAC, which is the hydraulic model. Here we make use of the function that we prepared before. This function is just an utility that transforms the data from the HYPE format to the TELEMAC format. I run it. It's asking me, are the TELEMAC subcatchments and the hydrological, the HYPE subcatchments consistent? In this case, I say yes. We already verified. This is just to check. It's a check if your data matches. And this is how the data are transformed. So we have now the unit of measure, the number of the subcatchments, etc. Then we just need to export the data, and they are ready to be used as input data in TELEMAC.